Okay, we're going to go over this review. Just a quick note, I'm kind of doing, excuse me. So I'm going to kind of go over this fairly quickly. Obviously, if there are follow-up questions, detailed questions, those you should ask in class. I'm probably going to make some mistakes here and there. I'm trying to get this done in like one take. I may break it up into a couple videos for you guys because it's going to probably get a little long. But I am doing this kind of like in a one-shot deal. So around the end, I'm going to get tired and I'll start making mistakes. That being said, let's look at 1A. So what do we got here? So we're asked to determine we're supposed to use the definition of continuity, determine if the function is continuous at a specific point. So in this point at x equals 2. So we have this function, this piecewise function, where we have the linear function x minus 4 on top for all values in the domain that are less than 2, and then finally negative 0.5x squared for all values greater than or equal to 2. Okay, so let's see what we got here. So I want to figure out, is there an issue at 2, right? Is the function continuous at 2? So this is a line and this is a quadratic. Both of these functions are continuous on their domain. So really the question becomes, right, is do these functions touch at x equals 2? So what I'm going to do is I'm going to do a couple things here. So using our definition, let's think about what our definition here is. I want to know, is this true? Is f of 2 defined? And I think you guys would agree it's absolutely defined, right? I can plug 2 into this function. Now it's going to come a number. So let's do that. So f of 2 equals negative 0.5 times 2 squared. I'm going to actually figure out what that is in this case. So that's negative 1. I'm just going to convert that. Negative 1/2. 2 squared is 4. 4 times negative 1/2 is negative 2. Okay, so I have shown that f of 2 is defined, right? First part of being continuous, taken care of. Now let's go and look at the limit. Does the limit as x approaches 2 of our function exist? Okay, well in this case, right, I'm going to have to look from the left and to the right of 2. So in other words, I'm going to have to look and see what is the limit as x approaches 2 from the left? What is the limit as x approaches 2 to the right? Are those numbers the same? That's really important. So let's go find out. So the limit, what is the limit as x approaches, what did I say? Approaches 2 from the left of the function. So I'm going to be using, in this case, I think you guys would agree, I'm going to be using that top function in order to evaluate this. So let's see what we get. This is going to be equal to 2 minus 2, which equals negative 2. And then the question is, what is the limit as it approaches from the right? Well, let's find out. The limit as x approaches 2 from the right of our function, now I'm going to be using, I think you guys would agree, that negative 0.5x squared. What does that equal? That also equals negative 2. So I think you'd agree the limit as x approaches 2 from the left of the function equals the limit as x approaches 2 from the right of the function, because they're both equal to negative 2. So conclusion, limit exists, right? So we know 2 things so far. We know f of 2 is defined. We know the limit exists. The last thing we have to do is we have to show that this and this are equal. If those 2 things are equal, the function is going to be continuous. So let's see. I'm going to say f of 2 equals, what did f of 2 equal? F of 2 equaled negative 2, which happens to be equal to the limit as x approaches 2, right? It is 2 of f of x, so this is also true. Therefore, I'm going to make my conclusion. What is my conclusion? Let's do that right down here. Conclusion. f of x is continuous at x equals 2. Okay? Let's keep on going. Let's move on to 1b. So same type of question. In fact, it's really the same question, just a different function. So let's see what we got here. So we have the function f of x equals this. So this is, top function is x squared plus 3x minus 10 over x minus 2, and the bottom function is 4. So this is when x equals 2, and this is when x is not equal to 2. So I think you guys would agree, we do know that f of 2 exists, right? F of 2 equals 4. So f of 2, let's just start there. F of 2 equals 4. So it is defined. Nicely done. Okay, let's go and find what is the limit, right? Now, in this case, right, all I have to do is look at the left and the right, because when I look to the left of x equals 2, I use this function. When I look to the right of when x equals 2, I use this function. This is only when I look at x equals 2 specifically. So I'm going to go and take the limit. Let's see, where am I going to do that? I'm going to take the limit, how about right here? I'll take the limit as x approaches 2 of the big function, right? So let's go and factor that. I'm going to kind of get started here. So the numerator is going to be, looks like it's going to be x plus 5, x minus 2. Let me double check. X squared, yep, looks good. The denominator is x minus 2. So in this case, I think you guys would agree, I'm going to be able to cancel out an x minus 2 from both top and bottom. So let's do that. There we go. So our similar function is this, and when we evaluate it at 2, we get 2 plus 7. So the limit of this function, right, if I wanted to kind of make a conclusion, I wouldn't necessarily have to do that, but for you guys, I'll do it. I'll say the limit as x approaches 2 of f of x equals 7. That would be my conclusion. Now, sorry, that conclusion to that part. The question is, does the limit exist? Yes, the limit does exist. It equals 7. So the third part is, does the limit equal the function evaluate the number? So in other words, is this true? And I think you guys would agree it's not, right? Because, let's kind of squeeze this in. This equals 4. This equals 7. 4 doesn't equal 7. Therefore, the function's not continuous at x equals 2. So let's write our conclusion. F of x not continuous at x equals 2. Be specific, because, right? Because f of 2 is not equal to the limit as x approaches 2 of f of x. By the way, I do see it. I see it. That should have been a 2. See, I told you I was going to make some mistakes. There was the first one. Hopefully just the first one. I may have missed some others. But anyway, what I want to emphasize here is don't just say it's not continuous. Be specific. It's not continuous because this is the specific part of the definition that it is breaking. Okay? Let's continue. Okay. We are supposed to find the limit of each function algebraically. So we are not using a table. We are not graphing. We are just going through algebraically and determining what our limits are. So let's start with, I'm going to start with 2a. What is the limit as t approaches 3 of t plus 2 over t squared minus 4. Now, I want to emphasize here, we've talked about this. I should always start with direct substitution, because if direct substitution works, then I can just, that's my value. In this case, the only issues occur, right, when t equals positive 2 or negative 2, that causes the denominator equal to 0. Everywhere else is good. So what is this limit? Well, the limit is just going to be 3 plus 2 over 3 squared minus 4. Now you might say, could I have factored? Right? Could I have factored out a t plus 2 out of top and bottom? Sure. But you didn't need to, because it wasn't a point, there wasn't an issue there. You're just going to get the same value. Okay, let's keep on going. Let's go on to b, or not to be. See? Let's see. And you guys think I don't know any English. Shakespeare. Let's see what we got here. I'm trying to make my handwriting a little neater. I don't know if that's working out too well. Okay, so again, I'm going to try direct substitution. If I plug in 5, I think you guys would agree there's an issue, right? Because in the numerator, 5 minus 4 is 1, 1 minus 1 is 0, 5 minus 5 is 0, we have 0 over 0. That's indeterminate. I don't know what's going on there. So, is there a way I can cancel out a 0 from top and bottom? Well, I'm going to multiply both top and bottom by the conjugate of the numerator. So let's do that. So x minus 4 plus 1 over x minus 4 plus 1. I know I'm forgetting to say the square root. You guys can see what I'm writing. Okay, what do we get? Well, we get the limit as x approaches 5. In the numerator, it's going to be the square of the first. That's x minus 4 minus the square of the second, which is 1, all over that denominator, which is x minus 5 times the square root x minus 4 plus 1. Hopefully I did that right. Okay, let's keep on going. Where is this going to go? I do not know. The limit as x approaches 5, the numerator is going to be x minus 5, and then it's going to be x minus 5, and this stuff. Okay, from here, oh, look at that. How convenient, right? We got a factor from top and bottom that we can cancel out. So we can cancel out that 0 from top and bottom, which is exactly what we want. So our similar function, right, is this. Now, wow, my handwriting is just terrible. Okay, now I can plug in 5. Let's see what happens when I plug in 5. Here's my step of calculus. So this is 5 minus 4 plus 1. Perfect, right? Perfect. That's a number. So our limit is whatever that value is. Couple notes. I do want to remind you. You cannot get rid of this symbol. This is an operation, right? It's a calculus operation. You're taking the limit. You can't get rid of it until you do your direct substitution. So in other words, I couldn't get rid of it until I did this step right here where I did my direct substitution. Otherwise, every step it needs to show. Let's keep on going. Let's go on to C. What do we got here? So we got the limit as t approaches 4 of t squared minus 16 over t minus 4. Okay, well, I think you guys agree. Try direct substitution, it fails. So I'm going to see if I can find a similar function. And just to be clear, right? When we plug in 4 from top and the bottom, we get 0 over 0. That's indeterminate. So that's not going to work. So I'm going to factor the numerator. I get t plus 4, t minus 4 over t minus 4. From here, oh, look at that. Very convenient again. We get a canceling out from both top and bottom. So our similar function is this. Now to do our calculus, we get 4 plus 4. So our limit, right, in this case is whatever that value equals. Okay, let's keep on going. Let's go on to D. I'm going to go through all the way through F, and then I'm going to kind of stop this video so that you guys can get a little break and I can get a little break, and I don't know. What do we got here? We're going to take the limit as t approaches 3 of 4 times the sine of pi t minus 6 plus the square root of, oh, why didn't that show up? T plus 7. Let's just make sure I wrote that down right. 4 sine pi t minus 6 plus, yep, looks good to me. Okay, there are a few different ways you can do this. You could just go for direct substitution right off the bat. What I'm going to do is I'm going to use the properties. I think it's going to make it a little bit easier for me. And also, it's a good review of the properties anyway. So I'm going to take the limit as t approaches 3 of 4 times the sine pi t. And I'm going to subtract that from the limit as t approaches 3 of 6 plus the limit as t approaches 3 of the square root. Okay. If I wanted to, right, I could take this 4 and move it out in front. In fact, let's do that. I'm going to, just because it's pretty quick because I can copy and paste, let's go and do that. I'm going to take that 4 and pull it out in front. There. Okay? So I can absolutely do that. And you can too. So that's just using our properties. Let's see what we get in this case. So I'm going to get 4. So this is going to be, I can do direct substitution with there. This is going to be sine of 3 pi, right? Because t is 3, minus the limit as 3 approaches 6. That's a flashcard. Is that 6 plus 3 plus 7. Cleaning this up a little bit, this becomes sine of 3 pi is 0. So my final answer is that. Okay? Easy peasy. Let's continue. Let's go to E. So for E, what do we have? We have the limit as x approaches 0 of sine 4x over 2x. Okay, so again, I should always try direct substitution. In this case, I think you guys would agree. I get 0 over 0, so it's indeterminate. That's not going to work. The question is, can I turn this into one of my flashcards? And as you guys know, I look at this and I say, man, if these were either both 2x or both 4x, I would be super happy. I can't turn the 2x, I can't turn the 4x into a 2x because it's within the sine function. But I think you guys would agree I should be able to turn the denominator into 4x. And I can do that by multiplying the numerator by 2 and the denominator by 2, right? Identity property multiplication, I haven't changed it. So what do we get? Well, we're going to get the limit as x approaches 0. The numerator, I'm just going to keep as sine 4x, and I'll be multiplying. I'll put a 2 in front of it, right? It's 2 times sine 4x. And the bottom is just going to be 4x. So keep on going. I'm going to pull that 2 out. You don't have to do this step. I'm just being fancy. This by flashcard, right? When I say this, I'm talking about this stuff right here is just 1. So we get 2 times 1. Okay, make sure when you're looking at yours, did you keep that limit as you went through? Make sure you did. Okay, this is going to be the last one for now, right? In this video, because we're keeping it short. What are we at here? Wish my recording thing had a timer on it, but it feels long. I feel like I've been doing this for 30 hours or 20 minutes. I don't know. So what do we got here? Okay, well, I'm going to break this up into 2 functions or 2 limits. So I'm going to say the limit as x approaches infinity of 8 plus the limit as x approaches infinity of 1 over x. Well, for the first one, this is a flashcard, right? This is just a horizontal line whose height is always 8, right? So the output of the first one is just 8. What about the second one? Well, we know this one. This is a flashcard. This goes to 0. So it is 8 plus 0. Okay? So that's what we're going to stop there for right now. And then when I come back, we will maybe finish. Maybe I'll break this up into 3 videos. We'll see where we're at. I don't know.